classmates. Velocity is best, you better hold it. In this course, you're gonna wanna go the distance. So if you can't integrate, then just forget it. That ain't what you want, that ain't what you want. Calculus what you want, calculus what you want.
First things first, we'll be starting with the limits and the properties, evaluating graphs analytically. Plug it in and factor them, and then you solve it graphically. Numerically, continuity, make sure you don't forget differentiability. Don't get confused with these. Just because f is continuous doesn't mean it's going to be differentiable. Let's see, watch out. Don't forget these limits have opposite sides, because if you do, you'll be lying on the bathroom floor crying.
Hit me with that calculus. You cannot derive, you're a tourist. I'll be studying here with my classmates. So if you ain't gonna help, then just forget it.
Hey, that's good, Captain, but you're forgetting something big, mate. If you want to do all this, you gotta know how to differentiate. Let Cam give you a quick lesson. He'll review all the types, because if you don't know these, then, well, you're in for a pretty bumpy ride.
Okay, derivative of x to the n is n times x to the n minus 1. Easy good, because that's just the basic stuff. Now the trig functions y from sine of x is cosine x. Get these straight, then you walk the halls, flexing with them checks. Comes the chain rule. Derivative of f of u is f from u times du over dx. Show your work, all the parts. Don't make it too complex, because soon you're gonna have to integrate. Just reverse these steps.
Hit me with that calculus. If you cannot derive, you're a tourist. I'll be studying here with my classmates. Wait, this problem's still wrong.
Dude, you forgot to change the radians. You didn't even add a constant. Here, you guys want to get a 5? Hey, play that beat back real quick.
You keep wondering why you keep getting these wrong. It's cause you don't pay attention to the details. What you done?
Hello, my name is Osman Anwar. This is an introduction video. My background is I have MBA and I have Masters of Science in Engineering Mathematics, which is applied mathematics, and I also have Bachelors of Science in Electrical Engineering. I have worked as an engineer in a semiconductor industry, in military and automotive semiconductors. I also have worked in wireless industry as a software quality assurance. I have worked on smartphone and cell phones. Also, I have worked in educational solution industry, which is TI calculators and other educational solution products. And I have been a professor of engineering and business mathematics for the last few years. Some of the courses I have taught and tutored are I have engineering calculus 1, 2, and 3, business calculus, finite math, business math, which is PreCalculus, trigonometry, college algebra, and more. I have some examples of this is examples of calculus 2. The first example is trig substitution, where the substitution is x equals sine theta, dx is cosine theta, d theta, and this is used to solve this integration from 0 to half x cubed square root of 1 minus x squared dx. When you do the trig substitution as x sine theta and dx cosine theta, then you will end up solving this integration. Then I have also a trig substitution of integration dt over t squared square root of t squared minus 9. This is obviously the trig substitution is t is 3 sec theta, dt is 3 sec theta tan theta d theta. Then you do the trig substitution, you will end up with square root of t squared minus 9 over 9t plus c. So this is basically just an overview of the solution. And here I have another example. This is volume by cylindrical shell method, which is a disk method, and this is when you rotate the area bounded by y equals x squared and y equals 8 minus x squared about the x equals 2. You sketch the region, of course, then the radius is r equals 2 minus x. The circumference is 2 pi r, which is 2 pi times 2 minus x. The height is f of x, which is the top curve, minus the bottom curve. So when you do that, the height is 8 minus 2x squared. Then the volume is just from a to b 2 pi r f of x dx. That's the integral of that. So that is from minus 2 to 2 pi. R is 2 minus x, and the f of x is 8 minus 2x squared dx. When you integrate this, we'll end up with 256 pi over 3. Then I have another example, calculus 2, and this is representing a function as a power series. So this is the derivative of 1 over 1 plus x. It represents this as a power series. So this is the same as representing d by dx, this power series 1 minus x plus x squared minus x cubed plus x to the 4. This is the standard. So when you take the derivative of this is minus 1 over x plus 1 squared, and you take the derivative of the power series, which is minus 1 plus 2x minus 3x squared, and so on. So this can be written in a sigma notation, n equals, in a sum notation, n equals 1 to infinity minus 1 to the n times x to the n minus 1. Then I have here another power representation of ln 4 minus x. This is the same as the integration of minus 1 over 4 minus x dx. So that integration is the same as ln 4 minus x, and this can be written as 1 over 1 minus x over 4. Then this can be written in a power form. The power series of this is 1 plus x over 4 plus x over 4 squared plus x over 4 cubed plus x over 4 to the 4 plus x to the 4 over 5, and so on dx. When you integrate this, you will end up minus 1 over 4. The integration of 1 is x, then the integration of this is 1 over 4 x squared over 2, 1 over 16 x to the third over 3, plus 1 over 64 x to the 4 over 4, plus 1 over 256 x to the 5 over 5. Then this can be written in a sum notation, minus 1 over 4. So the x's are x to the n plus 1, they are increasing by 1, and the 4's are increasing by 2, that's they are 4 to the n. Then you have 2, 3, 4, 5, which is n plus 1. Okay. So this is basically the power series of ln 4 minus x. Then I have here area in a polar coordinate. If you have r equals 6 cosine theta, to write this, to find the area of this in a polar coordinate, this polar coordinate, it is a equals 9 pi. So in this is basically a equals from 0 to pi over 2 half r squared d theta, which is from 0 to pi over 2 half. R is 6 cosine theta. Then this cosine squared theta can be written as 1 plus 2 cosine 2 theta. Then when you integrate this, you will end up with 9 pi. So you take the integration from 0 to pi over 2, which is only the top half circle, then this times 2 is you just double it, then you have the whole circle. Okay. Then I have another trig substitution. So this is the integration of dx over x squared square root of x squared minus 4. So this is obviously x equals 2 sec theta is the trig substitution, then dx is 2 sec theta tan theta d theta. Then when you substitute, you will end up with 1 over 4 cosine theta d theta integration. When you integrate that is 1 over 4 sine theta plus c. Then this is when you draw this triangle, this is theta, so sine is opposite over hypotenuse, which is square root of x squared minus 4 over x. Okay. And I have here some beautiful three-dimensional pictures of this is to show the beauty of mathematics. Beside every technology we enjoy, here are some beautiful math images. So this is actually, this is a polar, this is an trigonometry graphs. Those are in polar coordinates graphs. Then I have here area of surface of revolution examples. So for example, here you have a cylinder. So when you cut this, so the surface area of the cylinder is simply just the area of this rectangle. Okay. Then I have here area between two curves. So to find the area between the two curves in calculus, you basically integrate the top minus the bottom from A to B. So you will get this area, the top minus the bottom integration, and you evaluate it from 0 to 1, for example here. And this is the top curve minus the bottom curve. You integrate from 0 to 1. Then this is the right curve minus the left curve. You integrate this from minus 2 to 4. And here also you have the integration of the right curve minus the left curve, integrated from minus 2 to 4 again. Okay. Then I have here examples of some pictures of volume by slice method. For example, this is a sphere. When you cut this sphere into discs vertically, then you add all these discs, then you get the volume of the sphere, and so on. The other figures the same. Then I have here volume by cylindrical shell. You revolve this figure and you get, and you end up with you will integrate you will cut basically a cylindrical shell out of the figure, and those are, you add those, you integrate those, and you will end up with you will end up solving the integration basically. Okay. Here I have examples of calculus 2. The first example already we have seen. This is when the setup is x equals sine theta, dx is cosine theta, d theta. When you integrate this, we have seen this example. And I have another example, which is, we have seen this example also, where t is 3 sec theta, d theta is 3 sec theta tan theta, and you integrate this. Then I have an example of partial fraction integrals. So if you want to integrate x cubed minus x squared plus x plus 2 over x to the 4 plus 5x squared plus 4. So if you factor the bottom into x squared plus 1 times x squared plus 4, then this can be written as partial fraction ax plus b over x squared plus 1 cx plus d over x squared plus 4. Then you integrate this, you find the values of a, b, c, and d. Then this is the integration of this is tan inverse of x plus half ln x squared plus 4 minus tan inverse pi over 2 plus c. Then I have here integral of application of integral area between two curves. So this is, you have the right curve is y x equals e to the y, and the left curve is equal to y squared minus 2. So the area is the right minus the left, integrated from minus 1 to 1 from bottom to top. So when you integrate, you will end up with e minus 1 over e plus 10 over 3. Then here I have another example. It's polar equation and Cartesian equation. This is a conversion from polar to Cartesian, Cartesian to polar. So the A is polar to Cartesian, so you have r squared sine 2 theta equals 2. To convert this into Cartesian equation, so this is r squared sine 2 theta, this equals 2, which is r squared 2 sine theta cosine theta equals 2, which is 2r sine theta r cosine theta equals 2, but we know that r sine theta is y, r cosine theta x, that is 2yx equals 2, that is xy equals 1, which is y equals 1 over x. Then Cartesian equation to polar, for example, if you have y equals 2x plus 5, then to convert this, y equals 2x plus 5, which is y is r sine theta equals 2, x is r cosine theta plus 5, that is r sine theta minus 2 r cosine theta equals 5, that is r equals 5 over sine theta minus 2 cosine theta. And I have an application of volume by cylindrical method. So this is, you have two curves, y equals x to the third, y equals x, and you are revolving this about x-axis. So you identify the outer radius, which is x, the inner radius is x cubed, then the washer, the disk area is ax equals pi, the outer radius x squared minus the inner radius pi x cubed squared, so that is pi x squared minus x to the 6. Then the washer volume is from a to b ax dx. You integrate this, so that's from 0 to y pi x squared minus x to the 6 dx, which is pi x cubed over 3 minus x to the 7 over 7. You integrate this, you will get 4 pi over 21. So that's the area between these two curves. Then I have another application of volume by cylindrical shell. So this we already have seen. This is the volume rotated, the area between y equals x squared and y equals 8 minus x squared, about x equals 2. Because the graph, the radius is r equals 2 minus x. The third component is 2 pi r, which is 2 pi times 2 minus x. The height is f of x, which is the top curve minus the bottom curve, 8 minus 2x squared. Then the volume is from a to b, 2 pi r f of x dx, from minus 2 to 2 pi 2 minus x times 8 minus 2x squared dx. you integrate this, you will end up with 256 pi over 3. Okay. Then I have another example of the arc lengths in a polar coordinate, in the parametric arc coordinate. So the parametric is where x equals 8 cosine theta, y is a sine theta, where sine t, where t is between 0 and 2 pi. So dx by dt is minus 8 sine t, dy by dt is 8 minus 8 cosine t. Then the arc length is from a to b, square root of a, dx by dt squared plus dy by dt squared, integrated with respect to time, with respect to t basically. So this is from 0 to 2 pi, so minus 8 sine t squared plus 8 cosine t squared dt. When you integrate this, you will end up with 16 pi. So that is the arc length of this parametric equation. Then I have area of in polar coordinate. This we already have seen before. So this is r equals 6 cosine theta. Sketch the graph. So the area is, you find the area of the top half circle from 0 to pi over 2 half r squared d theta. When you integrate this, then you double this by multiplying it by 2. That will give you the area of the whole circle, which is 9 pi. Then I have here, this is representation in of the power series. So this is, we already have seen, it is d by dx of 1 over 1 plus x. So this is the same as the derivative of this power series, 1 minus x plus x squared minus x cubed and so on. So the derivative of this is minus 1 over x plus 1 all squared. Then the derivative of the power series is minus 1 plus 2x plus minus 3x squared. The signs are alternating, so this is minus 1 to the n. Then you have 1, 2, 3 and so on, that is n. Then x to the 0 to the 1 to the 2 to the 3rd to the 4th, that is x to the n minus 1. And where n is from 1 to infinity. Then I have another power series, which is ln 4 minus x. This is the same as minus integration of 1 over 4 minus x dx, which is minus 1 over 4. 1 over, this can be written as 1 minus x over 4. Then this is minus 1 over 4 integration of this power series, which is 1 plus x over 4 plus x over 4 squared plus x over 4 cubed plus x over 4 to the 4 and so on. Then this can be written in a sigma, in a sum notation, where n equals 0 to infinity, x to over 4 to the n dx. Then when you integrate this is the same as integrating this power series. So the integration of this is ln 4 minus x. Then the integration of the power series is minus 1 over 4 x plus 1 over 4 x squared over 2 plus 1 over 16 x cubed over 3 plus 1 over 64 x to the 4 over 4 plus 1 over 256 x to the 5 over 5 and so on. So this can be written in a sum notation, minus 1 over 4, n equals 0 to infinity. The x's are, the power are increasing, so it is to the 0, to the 2nd, to the 3rd and so on. So that's x to the n plus 1, 4 to the n. So then you have 2, 3, 4 and so on, that is n plus 1. Then I have, this is Maclaurin series of f of x to pi x. So the Maclaurin series of this is 1 minus 2 pi squared over 2 factorial x squared plus 2 pi to the 4 factorial x to the 4 minus 2 pi to the 6 over 6 factorial x to the 6, 2 pi to the 8 over 8 factorial x to the 8, and this is basically where this can be written in a sum notation from minus 1 to the n. This is alternating, so 2 pi to the 2n over 2n factorial x to the 2n. So to find the radius of convergence, you take the limit as n approaches infinity of an plus 1 over an. So that is, you'll end up with 0. That means the radius of convergence is infinity. That means it converges for every value of x. Then I have this example. If Taylor x series for f of x equals sine x at a equals pi over 2, so this Taylor series, you will end up with 1 minus 1 over 2 factorial x minus pi over 2 squared plus 1 over 4 factorial x minus pi over 2 to the 4 plus minus 1 over 6 factorial x minus pi over 2 to the 6 plus 1 over 8 factorial x minus pi over 2 to the power of 8. So you can write this in a sum notations from minus 1 to infinity, minus 1 to the n, 1 over 2n factorial times x minus pi over 2 to the 2n. So to find the limit, the radius of convergence of this, we take limit as n goes to infinity, an plus 1 over an, it will end up with 0. That means the radius of convergence is infinity. That means it converges for all values of x. Then I have here centroid region, application of calculus centroid region to find the centroid of region of the area bounded by y equals 2 minus x squared and y equals x. First you sketch the region, find the intersecting values by setting 2 minus x squared equals to x, then you will end up with a is minus 2, b is 1. Then the area is from a to b, top curve minus bottom curve dx, which is from minus 2 to 1, 2 minus x squared minus x, so you will end up with 9 over 2. So then to centroid of the region is x bar, y bar. To find the x bar, it is 1 over a from a to b x f of x dx, which is 2 over 9. From minus 2 to 1, you integrate this, you get minus 1 over 2. Y bar is 1 over a from a to b, 1 over 2 f of x squared dx, which will end up with 2 over 5. That means the centroid of this region is x bar, y bar minus half and 2 over 5. Okay. And here are some examples of calculus 1. The first example is find the limit using graphic method. So this is as limit x approaches minus 4.5. So minus 4.5 is here. From the left, this negative means from the left. So that means if you walk in this curve from the left, you will end up at 3. So the y value is 3. Then limit as x approaches minus 4 and half from the right, you walk only when you walk on this curve from the right, you will end up minus 6. So that means the limit from the right is minus 6. So the limit from the right is not equal to the limit from the left. That means the limit does not exist. That means limit as x approaches minus 4.5, f of x does not exist. So the f of x of minus 4.5, you stand here and you look up, it is a whole, so down it is minus 6, so that is the value of f of minus 4 to the half is minus 6. So this means this function is discontinuous. You have a whole, and it's obviously you can see from the graph. Then I have an example of limit at infinity. So given f of x equals x squared plus 5x plus 6 over x squared and minus 4. So this is equal to, if you factor the top is x plus 2 times x plus 3. You factor the bottom, it's x plus 2 times x minus 2. X plus 2 cancels x plus 2, so this is x plus 3 over x minus 2. So to find the x-intercept, you simply set the numerator equal to 0, which is x plus 3 equal to 0, that is x equals minus 3. Then to find the y-intercept, you simply put x equal to 0, so 0, 0 here, so that is minus 3 over 2. Then to find the vertical asymptote, we simply set the denominator equal to 0, which is x minus 2 equal to 0, that is x equals 2. Then to find the whole, you set the eliminated part, which is x plus 2, you set that equal to 0, then x equals minus 2 is the whole. Then to find the horizontal asymptote, you take limit as n goes to infinity of this one, or you can actually take of the x plus 3 over x minus 2, you will end up with 1. So this is basically you have all the information you need to graph this rational function. So then the next example I have is physics application in calculus. So you have distance formula is given, s of t of a bedrock is given 100 minus 10t plus 0.01 t cubed. So to find the distance at time t equals 2, then this is t equals to s of t, simply substitute 2, you will end up with 120.08 meter. Then to find the velocity at time t equals 2, then the velocity is the derivative of the distance is velocity. So you take the derivative of this, which is 10 plus 0.0013 squared. Then you substitute 2 into that equation. So that is, you will end up with, this is the equation, you will end up with 10.12 meter per second. Then the derivative of velocity is acceleration. If you take the derivative of this, which is 0.0306 t, then you evaluate this at 2, you will end up with 0.12 meter per second squared. Okay. I have another, this example is you have this cardboard, you have it is a square 12 by 12, then you cut in each corner x by x, then you fold it, you get this box. So then the cardboard is the width and length is 12 minus 2x, because you cut x by 2x from each side. Then the height is x. So the volume is 12 minus 2x squared times x. That's area of base times height, which is length times width times height. So then to find the maximum volume and the minimum volume for that matter, you take the derivative. The derivative of this is 144 minus 9 is 6x plus 12x squared. So that's the first derivative. If you take the second derivative, it is minus 96 plus 24x. So if you set the first derivative equal to 0, then you will end up solving this equation. You will end up x equals 2 and x equals 6. Then one of them will maximize the volume, will give you maximum volume, and the other one will give you minimum volume. So the way to find which one is max, which one is min, is you evaluate this 2 and 6 to the second derivative. So that is v double prime of 2, it is negative, it gives you negative value. That means that is concave down. Concave down means you have maximum. So that 2 will maximize the volume. Then if you put the v double prime 6 in the second derivative, you will end up with the positive value. Positive value means concave up. Concave up means you have minimum. So the maximum volume is, you put this 2 into the volume equation, which is 2 times 2 is 4, 12 minus 4 is 8, 8 squared is 64, 64 times 2 is 128, that is the maximum volume. Then if you put 6 into the volume, 12 minus 2 times 6, which is 12 minus 12, which is 0, so that the volume is 0. That means you completely destroyed the cardboard. It's 6 by 6, that means no volume, which is 0 volume. Okay. So here I have area between the two curves example. So this is you have the top curve 2x plus 3, and I have a bottom curve which is x squared. So find the point of intersection by setting the top and the bottom equal to each other. So that will give you a equals minus 1, b equals 3, which are these points and this point. Then you integrate this top curve minus bottom curve from minus 1 to 3. So you will end up with 10.67. Then I have here an example of related rate, which is medical application. You have tumor, cancer, growth due to tumor. So if you have, if it is in a sphere shape, and this tumor is shrinking due to medication, shrinking. So if it is shrinking at the rate of 1 millimeter per month, the radius, at what rate is the volume shrinking basically? When the radius is 3 millimeter. So you take, so the volume of the sphere is 4 over 3 pi r cubed. Then when you take the derivative, dv by dt is 4 pi r squared dr by dt, which is dv by dt is 4 over 3 pi 3r squared dr by dt. So that is, to find dv by dt is simply substitute the r's and the dr. So we know the r is 3, dr by dt is minus 1. So that will give you dv by dt is minus 36 pi millimeter cubed per month. What that means is, when the radius is shrinking by 1 millimeter per month due to medication, then the tumor itself, the volume is shrinking minus 36 pi millimeter cubed per month. That's a significant shrink, so eventually it will shrink and it will disappear. That's the idea. Okay, so this another example is related rate example again. So this is a boat is approaching is bullet to the dock by winch, and this winch is pulling this bag. The R is changing and the X is changing, but the Y is not changing, so the height of the dock is the same. So then this is the question here is while the radius of the winch is changing by 3 feet per minute, what is the change, how fast is the boat approaching the dock when X is 12 feet. Okay, so the first thing is in this triangle we know the X is 12, Y is 5, then we need to find the R. R is 13, which is R squared equals X squared plus Y squared. Then R squared is equal to X squared plus Y squared, but Y is 5. This is not changing, so we can just put the 5 here. Then when you take the derivative of this whole thing with respect to time, so this becomes 2R dr by dt, then 2x dx by dt, and the 5 squared disappears, is constant 0. Then you will end up with dx by dt equals r over x dr by dt. So dx by dt is, then we know r is 13, x is 12, and the dr by dt is given 3. Then dx by dt is 13 over 4. So that is what that means is when the winch is changing by 3 feet per minute, then the boat is approaching the dock at the speed of 13 over 4 feet per minute. Okay, so this is another physics application. Maximum height of a projectile. So this is the height of the projectile is given as minus x squared over 110 plus x plus 100. Then find where y is the height and the x is the horizontal distance. Then find the height of the maximum height of this projectile. So the maximum height is, you take the derivative, which is minus x over 55 plus 1. You set the derivative equal to 0, that will give you x equals 55, and that x equals 55 gives you the maximum height, which is h of 55 equals 127.5. That is the maximum height of the projectile. After that maximum height, it will drop. Okay, so here I have application of business calculus. The first example is it is medical application, blood flow in the blood flow to the heart due to the decrease in the radius of the when the radius of the artery increases due to medication or diet, then the percentage blood flow to the heart increases. When it is when the radius decreases, the percentage to blood flow to percentage blood flow to the heart decreases. So this is the formula is F equals KR to the 4. Then when you take the derivative of both sides with respect to time, dF by dt is equal to 4k r to the third dr by dt. Then when you divide both sides by F, then you will get the percentage blood flow. So this is 1 over F dF by dt is the percentage. 4 over R dr by dt is the percentage. So that means the percentage change of blood flow when R is 12 micrometer and dr by dt is minus 0.12 micrometer per year. That means the radius is decreasing, means the day radius is decreasing by this rate. That means the cholesterol is building up here. So that means the percentage blood flow is going to decrease by minus 4% per year. Okay, so that's blood flow decrease. On the other hand, is the percentage rate of change of blood flow. R is 12 micrometer and dr by dt this time is 0.18 micrometer per year. This is the radius is increasing, meaning there is a cholesterol, there is a cleanup of in the artery. The cholesterol is getting cleaned up. So at that means the percentage blood flow will increase by 6% per year. Okay. So this is an application, medical application of calculus. Then here I have a business application, marginal and derivatives. So this is the marginal profit. So given the cost function 10x plus 0.1 x squared. So this is for product by Axis company, and their revenue is 70x. Then their profit is revenue minus cost, which is 60x minus 0.1 x squared. When you take the derivative of the profit, you get 60 minus 0.2x. You said that equal to 0. That will give you the maximum profit, and the maximum profit is at x equals 9,000, which is that gives you the maximum profit of 9,000 when x equals 300. Okay. Here I have another example. It is medical application of calculus, and this is blood pressure in the artery, which is blood pressure to the heart. Basically, is given the rate of pressure with respect to time to the heart is given by minus 46.645 e to the minus 0.491 t, where t is in time, is time in seconds. Then when the heart is at rest at time equals 0, p is 95. Then find the function of the blood pressure, basically p of t. So when you integrate this this minus 46.645 e to the negative 0.491 t dt, you will end up with 95 e to the negative 0.491 t plus some constant k, but we know that at t equals 0 it is 95. You do that substitution, you will get k is 0, then the blood pressure is 95 e to the minus 0.491 to the t. then at t equals 0.1 second, that is after the heartbeat 0.1 second, then the blood pressure is 90.45. Then I have here an application of business application, maximizing profit in a monopoly market. So you have two kinds of market: monopoly market and competitive market. Monopoly market is when the market is monopolized by one entity, by one company. Then the competitive market is when you have several players in the market. So given the average cost is 300 plus 2x, and the price is 60 minus 1 over 2x, then the revenue is 60x minus half x squared, which is p times x. Then the total cost is 300x plus 2x squared, which is average cost times x. Then the total profit is minus 5 over 2x squared plus 300x, which is revenue minus cost. So then if you take the derivative of the profit, which is minus 5x plus 300, then you set that equal to 0, it will give you x equals 60. That is the maximum profit. Then find the p, the price at the optimal quantity, which is the p that gives you maximum profit, is when you plug that into the p function, you will get with equal to 570. Then the maximum profit is 9,000, which is at p equals 6, at x equals 6, so that is 9,000. Then I have here a plain trigonometry application, the examples. So this is what is called the cosine effect, that is between the radar reading and the actual speed. So when cars are traveling at some speed, then the radar is going to read at some angle, then that reading is going to be less than the actual reading by cosine theta. So theta is cosine theta is between minus 1 and 1. So when theta is 0 degree, then cosine theta is 1, then the reading is going to be equal to the actual reading, but any other angle will be less. So for example, if you have these two automobiles, they are traveling at the same speed, 75 miles per hour, 75 miles per hour, then the police points the gun, the radar at these two vehicles. So this one finds the radar reads for this is at 25 degree angle, and it reads for this one at 15 degree angle. Then when you do the actual reading is 75, the reading of the radar is 75 cosine 15 degree for the first car, then the 75 cosine 25 degree for the second car. Then for car A it is 72 miles per hour, for car P equals 68 miles per hour. So the police, if this is highway is the speed limit is 70 miles per hour, the police obviously will stop car A and will let the car B go, because the reading is less than the 70 miles per hour. Okay, although both of them are speeding at the same, they have the same speed. Okay, then I have here angular and linear speed of Earth is when it is revolving on its axis is for every 24 hours, where the radius of the Earth is 6,400 kilometers. So find the angular speed. The angular speed is omega, which is theta over t, which is 2 pi over t is 24 times 60 minutes. So this is pi over 720 radian per minute. Then if you multiply this 60 times 60, this will be per second, which is 2 pi over 43,200 radian per second. So the linear speed at the North Pole or South Pole, where the omega is 0, so the angle is 0, then the radius is 64,000, but since the angle is 0, so the linear speed at North Pole and South Pole will be 0. Linear speed at the equator is R equals R omega, which is 64,000 kilometers per hour. Then it is omega is pi over 720, so that is 80 pi over 9 kilometers per minute. And that is per minute. Per second is 4 pi over 27 kilometers per second. Then if it is in halfway from the equator, which is 45 degree, then V is R omega, omega R cosine 45 degree, pi over 4, then that will give you 40 square root of 2 pi over 9 kilometers per minute, or per second is 2 square root of 2 pi over 27 kilometers per second. Then I have here an example of solving a trigonometric equation 2 sec x plus 1 equals sec x plus 3. And when you solve this equation, you will end up with x equals pi over 3 and the x equals 5 pi over 3. When you solve minus 2 sine squared x equals 3 sine x plus 1, so this will give you at x equals 7 pi over 6, 3 pi over 2, and 11 pi over 6. So this is in a radian. Then in degrees, if you solve 6 squared theta plus times tan theta equals 2 tan theta, then when you solve this, as this is theta is 0 degree, 45 degree, 135 degree, 180 degree, 225 degree, and 315. When you solve tan theta plus 1 equals square root of 3 plus square root of 3 cotan theta, then those are the angles are here 60 degree, 135 degree, 240 degree, and 315 degree. Then here I have sketching a graph translation. So the original graph is y equals 3 sine half x. Then when you shift this up vertically by 3, then you shift it. Also, you have a horizontal shift, which is at x equals pi, shifted to the right by pi. Then this is the graph. So the way you find this is, first you find the amplitude. The amplitude is simply 3, and the vertical shift or shrink, there is no the vertical shift is 3. Then the period, you find the period is bx, which is half x, and that is equal to 2 pi. One complete cycle is 2 pi, that means x equals 4 pi is the period. Then the phase shift is, they said 1 half x minus pi over 2 equal to 0. Then this will end up x equals pi, so that is shifted to the right by pi. Then the one complete cycle is between 0 and 2 pi, and that is half x minus pi over 2. So that is add pi over 2 to all sides, so it's pi over 2 half x less 5 over 2, so that is 1 over 2x is between this, then multiply everything by 2, then x is between pi and 5 pi. So to sketch the graph, then 1 over 2x minus pi over 2 is between 0 and 2 pi, then x is between pi and 5 pi. Then to find the values of y is 3 plus 3 sine half x minus pi over 2. So we know the value of this, we simply plug those numbers here. So that is 3 plus 3 sine 0, so this whole thing is 0. You plug 0 here, so sine of 0 is 0, so that is 3 plus 0, which is 3. Then you plug pi over 2 here, which is sine of pi over 2 is 1, so this is 3 times 1 is 3, 3 plus 3 is 6. Sine of pi is 0, so that is 3. Then sine of 3 pi over 2, 3 pi over 2 is minus 1, sine of that is minus 1, so that is 3 times minus 1 is minus 3, 3 minus 3 is 0. Then at 2 pi it is again 3, so this is the graph. So this graph is shifted up, is sine curve shifted up by 3, which is the x-axis is here shifted up by 3, and also is shifted to the right by pi. So here it is pi, here is this is 2 pi, that means this is pi. Okay. Then here I have also the finding 2 minus 2i squared of 3, this is complex number to the power of 4. So this can be solved using trigonometry, and this gives you in the polar trigonometric form, which is easily solved. This is 256 cis 1200 degree, which cis means cosine of this angle plus I cosine I sine of this angle. So this is in the polar form. In rectangular form it is minus 128 plus 1 over 128i squared of 3, which is 256 cis 120, which is 256 cis 120. So you evaluate, so you will end up with 1 minus 128 plus I plus 128i squared of 3. So number 20 is finding the cubic root of minus 2 square root of 3 plus 2i, and this is when you apply in a polar, you convert this in a polar coordinate, you will end up cubic root of 4 cis 50, cubic root of 4 cis 170, cubic root of 4 cis 270 degrees. Those are the three roots, the cubic root of this function. Okay, then I have here business math, financial mathematics examples. So this is linear programming using graphic method. So you have here two kinds of product, chainsaw and clipper, chipper. So the chainsaw is X, the chipper is Y. Then the hours are 3 and 6. The profit for the chainsaw is 150 and chipper is 220. Then we are trying to maximize this profit. The maximum available is you have only 330. The numbers are less or equal to 30, and the hours are 120 or less. So that is maximize z equals 150x plus 220y. Subject is the constraint is x plus y has to be less or equal to 30, and 3x plus 6y has to be less or equal to 120. Then x, of course, x and y are greater than 0. So you draw this region, the feasibility region. So you have the x plus y is this curve, and the 3x plus 6y is this curve. So the feasibility region is, so this is below the curve, that means this is a visible region. Above the x-axis, to the right of the y-axis, so this is feasibility region. So we know this corner point is 0, 0. This corner point is 0, 20. This corner point is 20, 10. This corner point is 30, 0. So you identify the corner points, then you simply plug those corner points into the objective function, which is the maximizing function, z equals 150x plus 220. So when you plug 0, you get 0. When you plug 0, 20, you get 4,400. When you plug 20, 10, you will end up with 5,200. When you plug 30, 0, you will end up 4,500. So that means the maximum you will get is 5,200, and that is when you have 20, x equals 20, which is changed, so is 20, and cheaper is 10, which is y. Okay. So I have this another example, product exchange. So this is product exchange between gasoline and the hidden oil, and the relationship between them is y equals 125,000 minus 25x over 125 plus 2x. So to find the maximum gasoline, you set the y equal to 0, which is the x-intercept. So y is 0, so you set the numerator equal to 0. So that's x equals 5,000, that is the maximum gasoline. Then to find the maximum oil, you set the x equal to 0, that's the y-intercept, and that is 1,000. Simply you put x equal to 0. Then if the gasoline is 125, you put that into that's a formula, the equation, then you will end up with oil is also 215, which is this is when they are equal. Okay. Then here I have an example of feature value of compounded interest. So a developer needs 80,000 to buy land. So he is able to borrow the money at 10% per year, compounded quarterly. How much will be the interest? So to find that, basically the compounded interest formula is A equals P times 1 plus I to the n. You use this formula, you will end up with A equals the feature value is $131,089.32, and the interest is 51,000. So you can use this formula, or you can also use TVM solver in TI-84. You simply put the numbers. So n is, you put the n with the I, then simply you come here, you do the alpha solve, it will give you the solution. Then number 15 is also an ordinary annuity. A typical packet day smoker in Ohio spends about $170 per month on cigarette. Suppose the smoker invested that amount at the end of each month. That means the smoker quits smoking and puts this into an investment that gives 5.3% compounded monthly. What would be the amount in 4 years? So you can use this formula. This is S is the feature value of the ordinary annuity. R is what you put into the annuity. In this case, it's 170. Then times 1 plus I to the n minus 1 over I. So if you do that formula, the smoker, if that smoker quits smoking and put that money into the account in 4 years, that smoker will have 280,686. That is the feature value of that annuity, and of course the health on top of that. So you can confirm this using TVM solver TI-84. So you just plug the numbers and do alpha solver, you get the solution. Then I have another ordinary annuity payments application. This time we are going to figure out how much payment you have to make. So this is John Smith will purchase 300,000 home with a 25-year mortgage. So if he makes down payment 25%, then how much he should put? Well, the interest is 2.9% compounded monthly. What will be the monthly payment? So you use this formula. The present value equals of annuity is R times 1 minus 1 plus I to the minus n over I. So then that will give you R equals PI over that. Then you use this formula to calculate. The monthly payment will be 1,055. Confirm your answer using financial TVM solver. You can use TVM solver also. Basically, you put the information, alpha solve, will give you this value. Then I have here an application of matrix input-output analysis of economics. You have two economic basic products, wheat and oil, and the relationship between them is, this is the matrix relationship between them. A, an input-output matrix, 0.5, 0.16, 0.66, 0.22. The demand function is 750 for the wheat and 1,500 for the oil. So you do the TI solver, you can use I minus A all inverse D. If you do that, which is in identity 2 minus A in TI calculator, identity 2 minus A inverse D, you will end up with this solution. That means for this to meet this demand, you should have the wheat X is 2,901 and the oil Y, which is 4,378. Here also I have some examples of college algebra. This example is a rising balloon. So you are standing here and you are watching a balloon rise, and it's rising at 120 t. So t is time. The distance between you and the balloon is d, and the distance between you and the base is 400, and that is constant. So then the dt is basically d is x squared plus y squared, which is dt is square root of that dt is square root of x squared plus y. Then x, we know it is 400, square that, and y is 120t squared. Then when you solve this, you will end up with equation 40 square root of 100 plus 9t squared. Then evaluate that in 8 minutes. Then you will end up with 1040. That is how much the balloon rises in after 8 minutes. Okay, then I have here polynomial expansion using Pascal triangle. This is the Pascal triangle. At the top one, that means a plus b to the 0, a plus b to the first, a plus b to the second, a plus b to the third, a plus b to the fourth, a plus b to the fifth. So those are coefficients. So for example, to solve 2x plus 5 to the 5, to expand this using Pascal triangle, so first it is a plus b to the 5, that means a to the 5, the coefficient is 1 to the 5, plus 5 a to the 4, so that is 5, a to the 4 b to the 1, plus 10 a to the third b squared, plus 10 a squared b to the third, plus 5 a b to the 4 plus b to the 5. Basically, you have the coefficient, the power of a are decreasing, 4, 5, 4, 3, 2, and so on. The power of b are increasing, 0, 1, 2, 3, 4, 5. So then simply just substitute a for 2x and b is y. So you substitute, you will end up with 32x to the 5 plus a dx to the 4 plus a dx x to the 4y plus a dx to the third y squared plus 40x squared y cubed plus 10x y to the 4 plus y to the 5. Then I have here an example of rational function x minus 1 over x plus 2. So to graph this, first determine the vertical asymptote, basically set the denominator equal to 0. So that is x equals minus 2 is the vertical asymptote. Then determine the horizontal asymptote. So this is the horizontal asymptote is simply, it is the coefficient of x over coefficient of x, which is 1 over 1. So y equals 1 is the horizontal asymptote. Determine the x-intercept, simply set the numerator equal to 0, which is x equals 1 is the x-intercept. To determine the y-intercept, simply put x equal to 0, which is minus half is the x-intercept. Then to graph it, simply you put the vertical asymptote, the horizontal asymptote, the x-intercept, the y-intercept, then that is a graph. Okay. Then here I have examples of inequality. So this is y greater than x squared minus 4. So this is the curve. This is x squared shifted down by minus 4, and it is dotted because it is greater. There is no equal here. So then the shaded area is the solution. Okay. Then the y equal or greater, then this is not dotted, it's the same, but this is not dotted because it includes, it is greater or equal. Then this is above the curve. When it is less, it is below the curve. Dotted means it is less. solid line means it is less or equal. Okay, it is below the curve means it is less. And here I have development math examples. Linear inequality. So again, if you have 5x plus 3y greater than 5, then put this in the slope intercept form, which is y greater than mx plus b, which is, if you solve this, 5x plus 3y is minus 5x plus 15, then y is minus 5 over 3x plus 5. So that's the intercept. Then the slope is minus 5 over 3, b is 5. Then this inequality, it is the shaded area is the solution area, the feasibility region, and then you have this dot means it is greater. There is no equal sign here. Okay. Then here, if you want to factor k to the minus 2, 56k to the minus 10 completely, so you factor out the smallest power, which is k to the minus 10 is the smallest, so it's k to the minus 10. You factor that, then it is, what is left is k to the 8 minus 256, so that can be factored k to the 4 minus 16, k to the 4 plus 16. Then this can be factored k squared minus 4k squared plus 4. Then this can be factored as k minus 2, k plus 2. Then you will end up with k to the minus 10 times k minus 2, k plus 2, k squared plus 4, k squared, k to the 4 plus 16. Okay. Here I have an application of a rational expression. So on a US map, the distance between Seattle, these two cities, is 4.125. Then the other two cities, the two cities are actually this much. The distance between them is 1238. Then on the same map, what would be the distance between the other two cities, Chicago and El Paso? So first we need to read the problem carefully. Find the distance between Chicago and El Paso on a US map in inches. That is the question. So determine the ratio, equation ratio, which is x, that is what we are looking, over 4.125 in inch, is equal to the ratio between these two, 1606 over 1238. So you solve this for x equals 5.351 inch. So this is the distance between Chicago and El Paso in a map, in a map, yes. So this is in inches. Okay, then state the answer. The distance between Chicago and El Paso on a US map is 5.351 inch. Then I have here complex numbers, addition of all complex numbers. Simply you add the real and you add the imaginary. So this is 7 minus 4 plus 3 will give you 6. Then 3i minus 2i is 5i. 5i plus I is 6i. Okay. Then multiplication, you multiply two complex numbers. Those are conjugate complex numbers. That gives you 97. The multiplication of two conjugate complex numbers is always real. Then you have division of two imaginary complex numbers. Then you will end up minus 1 plus 2i. So that was the introduction. This video was just an introduction. Thank you, and have a nice day. Bye.